A steam engine is a heat engine that performs mechanical work using steam as its working fluid. Steam engines are external combustion engines, where the working fluid is separate from the combustion products. Non-combustion heat sources such as solar power, nuclear power or geothermal energy may be used. The ideal thermodynamic cycle used to analyze this process is called the Rankine cycle. In the cycle, water is heated and transforms into steam within a boiler operating at a high pressure. When expanded through pistons or turbines, mechanical work is done. The reduced pressure steam is then condensed and pumped back into the boiler. In general usage, the term steam engine can refer to either the integrated steam plants such as railway steam locomotives and portable engines, or may refer to the piston or turbine machinery alone, as in a beam engine and stationary steam engine. Specialized devices such as steam hammers and steam pile drivers are dependent on the steam pressure supplied from a separate boiler. Using boiling water to produce mechanical motion goes back over 2,000 years, but early devices were not practical. The Spanish inventor Jerónimo de Arians y Beaumont obtained the first patent for a steam engine in 1606. In 1698, Thomas Savery patented a steam pump that used steam in direct contact with the water being pumped. Savery's steam pump used condensing steam to create a vacuum and draw water into a chamber, and then applied pressurized steam to further pump the water. Thomas Newcomen's atmospheric engine was the first commercial true steam engine using a piston, and was used in 1712 for pumping in a mine. In 1781, James Watt patented a steam engine that produced continuous rotary motion. Watt's 10-horsepower engines enabled a wide range of manufacturing machinery to be powered. The engines could be sited anywhere that water and coal or wood fuel could be obtained. By 1883, engines that could provide 10,000 horsepower had become feasible. The stationary steam engine was a key component of the Industrial Revolution, allowing factories to locate where water power was unavailable. The atmospheric engines of Newcomen and Watt were large compared to the amount of power they produced, but high-pressure steam engines were light enough to be applied to vehicles such as traction engines and the railway locomotives. Reciprocating piston-type steam engines remained the dominant source of power until the early 20th century, when advances in the design of electric motors and internal combustion engines gradually resulted in the replacement of reciprocating steam engines in commercial usage, and the ascendancy of steam turbines in power generation. Considering that the great majority of worldwide electric generation is produced by turbine-type steam engines, the steam age is continuing with energy levels far beyond those of the turn of the 19th century. History. Early designs and modifications. The Aeoli pile described by Hero of Alexandria in the 1st century AD is considered to be the first recorded steam engine. Torque was produced by steam jets exiting the turbine. Thomas Savery, in 1698, patented the first practical, atmospheric pressure, steam engine of 1 horsepower. It had no piston or moving parts, only taps. It was a fire engine, a kind of thermic siphon, in which steam was admitted to an empty container and then condensed. The vacuum thus created was used to suck water from the sump at the bottom of the mine. The fire engine was not very effective and could not work beyond a limited depth of around 30 feet. Thomas Newcomen, in 1712, developed the first commercially successful piston steam engine of 5 horsepower. Its principle was to condense steam in a cylinder, thus causing atmospheric pressure to drive a piston and produce mechanical work. James Watt, in 1781, patented a steam engine that produced continued rotary motion with a power of about 10 horsepower. It was the first type of steam engine to make use of steam at a pressure just above atmospheric to drive the piston, helped by a partial vacuum. It was an improvement of Newcomen's engine. Since the early 18th century, steam power has been applied to a variety of practical uses. At first it was applied to reciprocating pumps, but from the 1780s rotative engines began to appear, driving factory machinery such as spinning mules and power looms. At the turn of the 19th century, steam-powered transport on both sea and land began to make its appearance, becoming more dominant as the century progressed. Steam engines can be said to have been the moving force behind the Industrial Revolution and saw widespread commercial use, driving machinery in factories, mills and mines, powering pumping stations, and propelling transport appliances such as railway locomotives, ships, steamboats and road vehicles. Their use in agriculture led to an increase in the land available for cultivation. There have at one time or another been steam-powered farm tractors, motorcycles and even automobiles as the Stanley steamer. The weight of boilers and condensers generally makes the power-to-weight ratio of a steam plant lower than for internal combustion engines. For mobile applications, steam has been largely superseded by internal combustion engines or electric motors. However, most electric power is generated using steam turbine plant, so that indirectly the world's industry is still dependent on steam power. Recent concerns about fuel sources and pollution have incited a renewed interest in steam both as a component of cogeneration processes and as a prime mover. This is becoming known as the advanced steam movement. Early experiments. The history of the steam engine stretches back as far as the 1st century AD, the first recorded rudimentary steam engine being the Aeolipile described by Greek mathematician Hero of Alexandria. In the following centuries, the few steam-powered engines known were, like the Aeolipile, essentially experimental devices used by inventors to demonstrate the properties of steam. A rudimentary steam turbine device was described by Taki al-Din in 1551 and by Giovanni Branca in 1629. Geronimo de Rianz y Beaumont received patents in 1606 for 50 steam-powered inventions, including a water pump for draining inundated mines. Denis Papin, a Huguenot refugee, did some useful work on the steam digester in 1679, and first used a piston to raise weights in 1690. Pumping engines. The first commercial steam-powered device was a water pump, developed in 1698 by Thomas Savery. It used condensing steam to create a vacuum which was used to raise water from below, then it used steam pressure to raise it higher. Small engines were effective though larger models were problematic. They proved only to have a limited lift height and were prone to boiler explosions. It received some use in mines, pumping stations and for supplying water wheels used to power textile machinery. An attractive feature of the Savery engine was its low cost. Bento de Moura, Portugal introduced an ingenious improvement of Savery's construction, to render it capable of working itself. As described by John Smeaton in the Philosophical Transactions published in 1751. It continued to be manufactured until the late 18th century. One engine was still known to be operating in 1820. Piston steam engines. The first commercially successful through engine, in that it could generate power and transmit it to a machine, was the atmospheric engine, invented by Thomas Newcomen around 1712. It was an improvement over Savery's steam pump, using a piston as proposed by Papin. Newcomen's engine was relatively inefficient, and in most cases was used for pumping water. It worked by creating a partial vacuum by condensing steam under a piston within a cylinder. It was employed for draining mine workings at depths hitherto impossible, and also for providing a reusable water supply for driving water wheels at factories sited away from a suitable head. Water that had passed over the wheel was pumped back up into a storage reservoir above the wheel. In 1720, Jacob Leupold described a two-cylinder high-pressure steam engine. The invention was published in his major work, Theatra Machinarum Hydraulicarum. The engine used two lead-weighted pistons providing a continuous motion to a water pump. Each piston was raised by the steam pressure, and returned to its original position by gravity. The two pistons shared a common four-way rotary valve connected directly to a steam boiler. The next major step occurred when James Watt developed an improved version of Newcomen's engine, with a separate condenser. Boulton and Watt's early engines used half as much coal as John Smeaton's improved version of Newcomen's. Newcomen's and Watt's early engines were atmospheric. The engine cylinders had to be large because the only usable force acting on them was due to atmospheric pressure. Watt proceeded to develop his engine further, modifying it to provide a rotary motion suitable for driving factory machinery. This enabled factories to be sited away from rivers, and further accelerated the pace of the Industrial Revolution. High-pressure engines around 1800. Richard Trevithick separately. Oliver Evans in 1801 introduced engines using high-pressure steam. Trevithick obtained his high-pressure engine patent in 1802. These were much more powerful for a given cylinder size than previous engines and could be made small enough for transport applications. Thereafter, technological developments and improvements in manufacturing techniques resulted in the design of more efficient engines that could be smaller, faster, or more powerful, depending on the intended application. The Cornish engine was developed by Trevithick and others in the 1810s. It was a compound cycle engine that used high-pressure steam expansively, then condensed the low-pressure steam, making it relatively efficient. The Cornish engine had a regular motion and torque through the cycle, limiting it mainly to pumping. Cornish engines were used in mines and for water supply until the late 19th century. Horizontal stationary engine. Early builders of stationary steam engines considered that horizontal cylinders would be subject to excessive wear. Their engines were therefore arranged with the piston axis vertical. In time, the horizontal arrangement became more popular, allowing compact, but powerful engines to be fitted in smaller spaces. The acme of the horizontal engine was the Cornish steam engine, patented in 1849, which was a four-valve counterflow engine with separate steam admission and exhaust valves and automatic variable steam cut-off. When Corliss was given the Rumford Medal, the committee said that no one invention since Watt's time has so enhanced the efficiency of the steam engine. In addition to using 30% less steam, it provided more uniform speed due to variable steam cutoff, making it well suited to manufacturing, especially cotton spinning. Marine engines. Near the end of the 19th century, compound engines came into widespread use. Compound engines exhausted steam into successively larger cylinders to accommodate the higher volumes at reduced pressures, giving improved efficiency. These stages were called expansions, with double and triple expansion engines being common, especially in shipping where efficiency was important to reduce the weight of coal carried. Steam engines remained the dominant source of power until the early 20th century, when advances in the design of electric motors and internal combustion engines gradually resulted in the replacement of reciprocating steam engines, with shipping in the 20th century relying upon the steam turbine. Steam locomotives. As the development of steam engines progressed through the 18th century, various attempts were made to apply them to road and railway use. In 1784, William Murdoch, a Scottish inventor, built a prototype steam road locomotive. An early working model of a steam rail locomotive was designed and constructed by steamboat pioneer John Fitch in the United States, probably during the 1780s or 1790s. His steam locomotive used interior bladed wheels guided by rails or tracks. The first full-scale working railway steam locomotive was built by Richard Trevithick in the United Kingdom on the 21st of February 1804. The world's first railway journey took place as Trevithick's unnamed steam locomotive hauled a train along the tramway from the Penwy Darran Ironworks, near Merthyr Tydfil to Abercynon in South Wales. The design incorporated a number of important innovations that included using high-pressure steam, which reduced the weight of the engine and increased its efficiency. Trevithick visited the Newcastle area later in 1804, and the colliery railways in northeast England became the leading centre for experimentation and development of steam locomotives. Trevithick continued his own experiments using a trio of locomotives, concluding with the Catch Me Who Can in 1808. Only 4 years later, the successful twin-cylinder locomotive Salamanca by Matthew Murray was used by the edge-railed rack and pinion Middleton Railway. In 1825, George Stephenson built the locomotion for the Stockton and Darlington Railway. This was the first public steam railway in the world, and then in 1829, he built the Rocket, which was entered in and won the Rainhill trials. The Liverpool and Manchester Railway opened in 1830, making exclusive use of steam power for both passenger and freight trains. Steam locomotives continued to be manufactured until the late 20th century in places such as China and the former East Germany. Steam turbines. The final major evolution of the steam engine design was the use of steam turbines starting in the late part of the 19th century. Steam turbines are generally more efficient than reciprocating piston-type steam engines, have fewer moving parts, and provide rotary power directly instead of through a connecting rod system or similar means. Steam turbines virtually replaced reciprocating engines in electricity generating stations early in the 20th century, where their efficiency, higher speed appropriate to generator service, and smooth rotation were advantages. Today most electric power is provided by steam turbines. In the United States, 90% of the electric power is produced in this way using a variety of heat sources. Steam turbines were extensively applied for propulsion of large ships throughout most of the 20th century. Present development. Although the reciprocating steam engine is no longer in widespread commercial use, various companies are exploring or exploiting the potential of the engine as an alternative to internal combustion engines. The company Energy Project AB in Sweden has made progress in using modern materials for harnessing the power of steam. The efficiency of Energy Project's steam engine reaches some 27 to 30% on high-pressure engines. It is a single-step, 5-cylinder engine with superheated steam and consumes approx. 4 kilograms of steam per kWh.